One of the most challenging things in software is making sure you implement the right features, that your software solves the right problems, and it does it the best way possible. So with our customers in Tanzu Labs, we work on a method called product validation, where we put in place a very basic lean software idea, which is build, measure, learn. You rapidly, on a weekly basis, figure out and try out new features and get a lot of validated learning about what works and doesn't work. And you're always incrementally, but consistently getting to a state where your software is better and you're solving the right problems. Let's go over what that looks like. And then we could be like, but I won't actually do that. Actually, that might be fun. First, let's start with how software is traditionally done. It's usually done in a assumption-based way of doing things. That is, on a long cycle, maybe a month, maybe 6 months, maybe even longer. The developers, the business analysts, they come up with some screens and features to implement, identifying what a problem is you're solving and how it should be solved. The developers go off and work on this, all sorts of other activity goes around them, and eventually they release the software to users, and then you get to see if the features are implemented, if the people using your software are actually accomplishing the things that you wanted. Let's start with an example. Let's go over an example of a Tanzu Labs project. It's the American tax collectors, the IRS, but I'm just basing my story on this because I don't know the actual details. So let's transform it to Beloved Tax Agency. Now, Beloved Tax Agency has to collect taxes from people to pay for roads, all those things that people enjoy. But sometimes people forget or neglect to pay their taxes, and they owe these back taxes. There's penalties to it. Every day it becomes more and more as a sort of crude notification system to get you to pay your taxes. Traditionally, before the Beloved Tax Agency put in place this solution with Tanzu Labs, they had a call center that you would call up and check how much you owed on a day so you could pay it. Now, this call center, there was a study by an external group that said it had about 37% availability. That was that you would be on hold forever, or the call would just drop, or you would just give up. Calling someone on a phone to handle something is not only an annoying, but also it's very expensive to staff a call center and handle all of that workflow through it. So Beloved Tax Agency had a theory. Their theory was that they were going to put some software in place that would allow them to have less people use the call center and do things as we would expect them nowadays through an app. So this is the original problem that the Beloved Tax Agency has. They want to transition to an app, pretty straightforward like this, that allows someone to log in and see all of the different things that they have and find out how much money they owe so that they don't call someone up and they can pay off their taxes. Now let's go into why this kind of approach often is not the best approach. You might even call it a bad approach. This kind of way of doing product development, where you think about what things should look like and you ship it and then you have your application, often takes too much time to get input on if it's the right way to solve the problem or not. And I think this is why you see figures as high as 95% of product launch failure, things that didn't accomplish your goals. I think with software, it's a little more realistic to be in the 50 to 70% range, according to a couple of decades of Standish Group study about software being delivered successfully or not. Why is this? Well, that's because when you're on a long cycle, a 6 or 12-month cycle, a lot of what you're doing is you have assumptions about what needs to be done. You assume that the problem that you're solving, you assume the right way to implement that problem in software, and you really don't get the chance to test those. And when you're on a 6 or 12-month cycle, this also means that as you observe that the software is not being used, that you're not accomplishing the goals that you have a much longer cycle to put new things in place. It takes you a long time, that 6 to 12 months, to correct the assumptions that you got wrong. So doing things in an assumption-based environment where you're not validating the assumptions you have leads to a lot of waste in the system. All the time you spent not only implementing the feature that didn't work out very well, but it also creates a waste in time to market. It takes you longer and longer to get the right feature into production. So if you have a long development cycle and you're doing it based largely on unvalidated assumptions, you can see that you have a tremendous amount of waste in the system. You spend a lot of effort implementing a feature that ultimately you have to change. You have a longer time to market because you're always waiting for each cycle to actually get your new features to market to change how the business is functioning. So what can you do instead? Instead, if you compress down the amount of time it takes you to release your cycle by doing smaller incremental features, you can start to get a lot more validation with how your products are done. What you do is you go through what I think of as the small batch loop. It's a kind of more detailed version of the build, measure, learn loop. They're both the same. So the first thing that you do is you come up with a theory of how you're going to solve the problem. Remember, with Beloved Tax Agency, they had a theory that was that we're going to show the transaction history and people will be able to find out how much money they owe. And then next, you build that. This is software, you've got to write the code, and it's important that you deploy that to actual end users. Now, you don't necessarily have to deploy to all the users at once. Using cloud native techniques that are built on things like Kubernetes, it's really easy to deploy to a small group of users to do A/B testing. If you have a population of 1,000 users, you could just deploy it to 10 users, because with a Kubernetes-based way of doing applications, you can actually deploy multiple versions of your application at once into production. Now, following this A/B approach, having one set of users, a small set use one piece of software, and your regular set of users use the existing one, is a good risk-managed way to test out new features. Now, the next part that's key that I think a lot of people leave off is coming up with very simple, very clear measurements. Let's think about the example of Beloved Tax Agency. Their business goal is to have less people call the call centers and to have more people be able to do this on their own. So their measurement might be something that when we put this new app in front of people, 50% of the people will be able to pay their back taxes without calling, and that will result in less people calling in. Now, I don't know if 50% is too high or too low. I don't know what the kind of rates here are, but let's just go with 50% because I don't know what it is. It can be whatever percent. So you come up with that metric. The metric that we are going to be paying attention to is we will be a success at our theory if 50% of the people who see our app are able to pay their taxes on their own and not call the call center. So then the next step is, as you observe people doing it, which means you need to be able to collect that data. So you've got to instrument your app to pull that data in to actually observe it. You learn, you analyze what happened. The learning is largely based on were we right? But what's key about the learning thing is if you are right or wrong, it allows you to figure out what to do next. If you are wrong, you can make the decision to try a new theory and go through the loop again. That's validated by the collection and the rigorousness that you had. You can decide to do more of it, to improve it even more, or you can decide to move on to something else. But this next step is key for deciding what you do next. So let's go back and see what happens with the Beloved Tax Agency. And again, this is based on facts, but I'm adding in details that I don't know if they existed or not. So that's why it's Beloved Tax Agency and not the actual one. If we go back, when Beloved Tax Agency deployed their application, they had their measurements in place. And what they observed was that many people, way less than 50% of the people, still called up the call center instead of paying the taxes on their own. When they interviewed the users, they found out that there was too much information. People were unsure what their actual balance was. Now, in this screenshot, what they needed to find is highlighted in orange so that you can cheat. But if you imagine that it's all in black and you've got like a big screen, just think of all the transactions in the history you've had with the Beloved Tax Agency over the years. It was difficult for them to not only find how much they owed, but have confidence that they're paying the right thing. Imagine if you owed $10,000 in back taxes. You would want to be very sure that it was the correct thing, and you might want to just call someone to verify. The theory that they had, the hypothesis of how they would solve the problem, turned out to not be correct. It didn't meet the measurements that they had. You could call that a failure, but effectively there's a new learning that they had. So they decided to go through the loop again. I'm sure Beloved Tax Agency came up with many new theories, and eventually they came to this one. So think about them coming up with new ones and going through the loop. But what they discovered, as you can see on the after side, is that when people wanted to know how much money they owed Beloved Tax Agency, they only wanted to know how much money they loved Beloved Tax Agency. So when people went into this workflow, how much taxes do I owe? They showed them only one thing. They filtered down to exactly what it was, and so that it added a huge amount of certainty, a huge amount of simplicity. This seems ridiculously simple once you've gone through it, but I imagine that many people who've worked in software have similar ridiculously simple features that they found through this kind of trial and error, or if you're lucky, through this very data valid way of doing things. This worked out great for Beloved Tax Agency. More and more people went through this workflow, didn't call the call centers. This fixes that 37% availability, moves it way up. And as you can see from the actual case study with the IRS, they're now moving hundreds of millions of dollars. They've been able to reduce down their release cycle quite a bit to get more validated learning in there. And overall, they've improved this one workflow through their system. And then for the management, the strategy, and the executive people out there, the ones who are always a little leery of going through this change of doing things on a weekly cycle, there's a lot of uncertainty and seeming risk to it, right? Here's an important way to think about how it's actually better to do things this way. And that is when you're doing things on a 6 or 12 month cycle based on assumptions instead of validated features incrementally done on a weekly basis, you're building up a huge amount of risk over time. And that risk is, did we do the right thing? And so the longer time you spent before releasing the software, you finally discover if that was right or not. And assuming 100% of things were right, your risk drops down to zero, right? So you've done something good. Now, Of course, it rarely ever drops down to zero. Just think if beloved tax agency had done it on a 6-month cycle, they would have had 6 months of risk and it would still be here. They would have done the wrong thing, so to speak. However, if you're incrementally doing things and you figure out how to release it more frequently, if you're getting validation along the way, instead, what you have the capability to do is you do build up risk to be sure, but because your cycles are on a weekly basis and you're validating it, you have a much better way of controlling your risk throughout. And I think this is key to change thinking about how you're making the business more effective. You're always figuring out how to build a system to gather the data, to get validation about the problems you're solving, how you're solving them, and you're ensuring that you keep that risk at a low level instead of doing the longer cycles that's based on a lot more assumptions. It feels a lot more confident at the beginning, right? Because you're delivering big chunks of things to make those business cases. You're going to be able to convert it over all at once. But doing it with the smaller user population to bring in that validation, doing experiments along the way is actually a much better way to manage not only the risk, the strategic risk of the project, but also the budget that you have. You can fund smaller and smaller budget things, and you can really cut a project if it just turns out to be an utter not helpfulness. I was going to say failure, but let's stay positive. How do you build a system to do that? It starts with that practice of putting in place validated learning with your development team, having the balance teams in place and other practices of doing development. But getting to a point where you can reliably and securely release code on a weekly basis takes putting in place a platform, often nowadays based on Kubernetes or the Tanzu application service, that allow your developers to focus only on that small batch loop and also allow them to very rapidly deploy features to production. Another key feature of it is that they can do that A/B testing where they develop the new features to only a small population, a small amount of users, so they don't risk putting the wrong features into production that messes everyone up, especially as you're improving your features. Also, it allows you to control the risk of bugs and errors getting into production. So if the idea of releasing your software on a weekly basis seems scary because you're going to bring down production, a lot of what's gone into building out the way Kubernetes works, the applications that are built on top of it, the configuration that happens, is built around this idea of managing the risk of deploying frequently and being able to roll back and contain that risk, being able to go back to a good version of it. And you also find these features in the Tanzu application service. It's really important to get that proper stack in place that allows your developers to release their software on a weekly basis and focus on just going through that cycle and studying what the actual people are doing to solve the problems. So if you're interested in more detail, go to the VMware Tanzu Learning Center and check out the ongoing foundations of modern development that the Tanzu Labs people have going on, and you can look at the product validation article. It's got a lot more detail and some great examples of what it looks like to have those kinds of tests. And as always, you can go to tanzutalk.com to find the archives and all sorts of links in the videos that we have here. We'll see everyone next time. Bye-bye.